Welcome everyone to this week's OMR Architecture Meeting. This week we have two compiler topics to discuss, both introduced by Ben Thomas. So I'll let him take it away and talk through 5517 and 5149. Ben?
Okay, so starting off, I'm just going to give a little bit of background. So currently, OMR already has an opcode for reversing the order of bytes in a 32-bit integer. So we already have an iByteswap opcode. And these kinds of opcodes are very useful for converting between big endian and little endian representations of integers. So these are really useful when you're doing things like you're required to put your integers in big endian form when you're sending them over a network protocol, or for certain languages like WebAssembly where it is strictly required that loads and stores act as if they were on a little endian system, because you can alias between loads of different types. So what I'm proposing here is that we add two new opcodes, sbyteswap and lbyteswap, to perform the same operation on 16 and 64-bit values. There is already code for doing this in OpenJ9 for, I believe it's XP and Z, that we can borrow to implement these on those platforms. So I don't think there's terribly much implementation work here, and these opcodes are basically analogous to our existing iByteswap opcode, but for 16 and 64-bit values. So I don't think there's terribly much going on here. One thing Andrew did bring up was the potential of also doing a byte swap. However, I haven't been able to come up with a compelling use case for doing this. Typically, if the user is provided with access to the individual bytes of a value, it's not usually a pointer. You wouldn't usually send pointers over the network or store them on disk, and typically in things like WebAssembly, even where little endian is strictly required, you don't really, you don't provide the user with direct access to sort of manipulate pointers. The pointers that are seen from the user perspective are just offsets into a sandboxed memory. So I'm not really sure what the use case of byte swapping an address would be. So I don't think there's a compelling enough case to add an address byte swap. But I think that for shorts and longs, there is a sufficiently compelling case here.
Is there a similar argument against doing this for floating point byte swap?
So the reason that I'm not proposing doing this on floating point values is because I don't actually know of any architecture that lets you do a byte reverse directly on a floating point value. So typically you would have to move it into a GPR, do the byte swap there, and move it back. So it would be better to just represent it as an integer byte swap followed by a bit conversion.
Okay, yeah. So there's a mapping to a convenient instruction on at least one platform in the cases that we are proposing. Okay, thanks.
Yes. So on XP and I believe Z, for P specifically, it's with P10. We have specific instructions for doing this efficiently. And even prior to P10 on Power, there are more efficient series of instructions you can use. So there is both use case for representing this in the IL from the user perspective, and there's optimization potential in the code generator.
Ben, just following up on the floating point question, if you were going to use, say, the iByteswap or the lbyteswap to do the floating point reversal, I'm a little, I'm not quite sure what the trees would have to look like for that, because if you added like an F to I or D to I or D to L or whatever to convert the type of the node, you would be implying changes in how the bit pattern is represented in memory because you're changing the type.
So you wouldn't be using an F2I or a D2L or anything. You would be using F bits to I and L and D bits to L.
Okay.
So we already have those opcodes to specify a bit for bit conversion between them.
Okay.
So does anybody else have any concerns they want to bring up here or anything?
Yeah, I mean, in terms of the precedent, I mean, we certainly, like you mentioned, already have an ibyte-swap. So I think that there shouldn't be any problem from a precedent point of view with extending this to the to these other data types.
Was the intent to also, so given that there's only one byte swap opcode present in the code base right now, there may be places that do certain optimizations checking for ibyte swap specifically. Is there an intent to also look at those places and see how, if some of them can be converted to using the sbyteswap query instead? I think you listed it in one of the properties or one of the comments in the issue that it'll have that property set, these two opcodes as well.
Right. I think there's a pretty limited set of places that do anything with the existing ibyteswap opcode. I don't think it's been even used in OpenJ9. There, it still uses recognized methods. But yes, I do intend to look at those locations.
Oh, okay. So the ibyteswap exists but isn't being optimized as such currently.
I believe there are some code gen side optimizations that go on, but I don't think there's anything in the optimizer, and I don't believe there's anything in OpenJ9 that uses them at the moment.
Okay. Okay, thanks.
Why we ended up in the state where we have an evaluator for integer, but then we decided to use recognized calls for the other ones for OpenJ9?
There is an issue that was opened, I believe, when that was introduced at 9.5.8. Let's get that open here. Of course, it's not working for me. This was just its introduction into OMR with the long byte swap opcode proposed to be introduced later. Sure, if there's one in OpenJ9 would have been the motivator for this. There may be an issue in OpenJ9 that talks about why they didn't use the opcode rather than the recognized methods. Check there as well. Seeing anything?
Yeah, I can't remember this coming up before, at least as long as we've been discussing IL changes, really. But that would be the only, I guess, concern if there was some, if we had gone through some evaluation of like the usual sort of process for deciding whether something should be a new opcode or not, and came to that conclusion for some reason that we somehow haven't been able to replicate in this meeting. That would be the only concern, but I can't think of one. It seems like a reasonable use case to me.
I agree. I mean, from a consistency and even completeness standpoint, having this makes it better.
Yeah.
I can't think of any issues either that won't have applied to iByteswap but do apply to these two. That's just very unlikely.
To guess, the reason why we have the I version was because of the data access accelerator library in OpenG9. Post up a link here. So this is why we have recognized methods, and at least for the short and long versions as well. So we recognize these APIs, and if the user wants big endian, they can supply a Boolean value versus little endian, and then we generate a reverse load store or a byteswap.
Yeah, that's useful to know. I think it's still the case that there's no good reason other than that was just the use case that was relevant for DAA or whatever the OpenJ9 issue that you mentioned. So we can't think of a reason not to introduce these.
Yeah, I agree with that. Okay. Any other comments on this or any objections to it, I guess? Sorry.
If I understand, we're all on the same page about sbyteswap and lbyteswap. Has anybody come up with a use case for abyteswap? Or does anybody have any reason that we should add that?
I'd rather not add it until we have a use case, though.
Yeah. I don't see any reason myself right now. So
presumably you could simulate it with either an iByteswap or an lbyteswap with an I to A or an L to A on top, right?
Yeah, you could do. So we can just go with these three for now.
Yeah, so we have a solution already for that problem if it comes up, and then we can evaluate whether it makes sense to.
Well, if the precedent is that for F and D you do F bits to I and D bits to L, then it would follow that A should go through either A to I or A to L, right? And there can be a comment to that effect put in the IL file where we document these that we've done. We're doing them simply based on the width, right? S, I, and L. And if you've got some other type that's carrying additional semantic information, you need to cast to the appropriate width and then do the conversion and then cast back if you need to.
Are there trill tests written for the iByte swap? And you'll just extend those for L and S?
No, there are not any existing trill tests for that. I would add tests for S, I, and L byteswap if I was going to add these, though.
Okay.
And going back to the prior point that Andrew was making, I think it would be good to document in some way the rationale for not introducing abyteswap at this point, because we started this meeting with there's an iByteswap in our opcode list, but we don't have these other ones. Does anybody know the reasons why that was done? And we don't want to have that conversation again. So documenting the discussion now would be good. When you add these, I mean.
Right. I have put an comment on the issue regarding abyteswap, but I could document it somewhere else if there's somewhere better that you think this should go.
Well, just for my personal opinion would be to put a comment somewhere in the code, possibly where we're declaring the properties or something like that, just to say that we're just using these ones for the widths and that we don't need the A and floating point equivalents because of, right? Just document it somewhere in the code where we codify the opcodes so that we don't have to go looking for a separate issue.
All right. That's fine with me.
We should probably actually, not that you have to do this as part of this issue, Ben, but we should probably just create a service for reversing the bytes of an arbitrary thing, and then either it returns the byte swap opcode or it builds a tree for the conversion.
Yeah, that would probably be useful. But yeah, I agree. That's somewhat beyond the scope of this right now.
Yeah, I'm not suggesting that you do that. I'm just, if we start using this, we should probably just do it right in one place. And
is there any support right now in like simplifier for byteswap? Or does it just do the most basic?
I don't think there's anything special in simplifier for byteswap right now.
Yeah, it is checking. No, it doesn't look like it.
Yeah, the set of stuff you can do in the optimizer with byte swaps is a little bit limited. You can constant fold them, and if you have 2 byte swaps in a row, you can eliminate them. But I don't see terribly many simplifier style optimizations that you really do on these things.
I guess that depends whether we're going to support reverse load store. Because if we are, then
right, there is also that.
Load. Yeah.
So I guess that moves us into our next topic of byte-reversed loads and stores. So OpenJ9 does currently have some byte-reversed load and store opcodes. Things like IRI load, which is supposed to load an integer and byte-reverse it simultaneously. This is technically a single operation on power. However, it has been brought up that it's probably better to target a pattern match in the code generator to do this rather than having special opcodes for it. So I'm of the opinion that probably we shouldn't move them in.
Sorry, by pattern match in the code gen, you mean a byte swap with a normal load under it get matched. Is that right?
Yeah. So a byte swap with a normal load under it, or a store with a byte swap under it.
I completely agree. I think we should have one or the other, not both.
Yeah, I don't personally see why we should have the complexity of the reversing load and store as a consideration throughout the optimizer when it's more of a convenience of a particular instruction architecture that you can do it in one step. I think it's better to express the step as a load and a reverse, and that just means that you can manipulate all of the stuff uniformly rather than having to worry about fused operations, which can always be a bit of a pain in the rear.
Yeah, that makes sense to me too.
And on that note, there is some code in OMR under J9 project specific for supporting those reversed loads and stores. Should we push for OpenJ9 to drop those opcodes after this and instead use the byte swap to get rid of that J9 project specific code?
Does anyone even know where we use those?
I believe those are DAA.
Sorry, Ben, by supported, you mean we have the code gen for them, but do you also know, I guess DAA would be the best guess for where they're produced. Is that right? Any other context for what generates them? I haven't.
The only thing I've seen that generates them is DAA.
Okay.
Yeah, just looking at the code, it should be fairly straightforward to just transform those to use a byte-swap on top of a normal load.
Oh, yeah, I mean, if it's only being used in the DAA code, that surely is an argument for not having them because of how special all the DAA code already is, right?
Yeah, there's. I don't even think there's an argument around the fact that if you didn't expose it as one indivisible thing, which is what I guess the IR load or IR store opcodes are, if you break them up into two things, I don't think there's an argument even that something would break if you separated those two parts, right? Like, for example, you have the byte swap. Underneath it, you might have an indirect load. But if you put that indirect load into a temporary and then did a direct load instead, you could still pattern match that and get the same result, presumably. So Philip, there's no functional reason for why the reverse load is created, right? Like one indivisible thing, like you can tolerate this sort of separation, I assume.
Yeah, without a problem. At the point of creation, the reverse loader stores are not common anywhere.
Yeah, I don't. If the DAA use case can deal with it, which is what seems like, there's no real argument for keeping them anywhere in my mind. Simplify things and remove it.
Yeah, I think the atomicity was the area that I was trying to think of an example where it would cause a problem too, but I can't think of one either unless somehow you would use a purely theoretical notion. You'd use some type of atomic load for the byte reverse load and you'd end up using a non-atomic version of the load. In the other case, you could get different behavior, but I don't think that's terribly likely. So, and I think anything else you can, if you happen to do different commenting on the load versus the byte reverse case, that would be another thing, but we can handle that in the pattern matching of the evaluator. And based on the use case that Philip just described, it doesn't sound like you'd have that very frequently anyway. So it seems, and beyond that, I completely agree with the orthogonality argument that everyone else is making too. This one sounds like a good one too, to me.
Yeah, I agree with all that, and plus the fact that there is no such atomic sort of implication in any opcode really that we have right at this point. So if that notion were to be added, I think it would be a bigger change anyway to the whole IL.
Well, and if there was an atomicity requirement, not every platform would be able to support it. So, right, because some platforms, especially like ARM or something like that, aren't going to have a single instruction to do it. You're going to have to load it and reverse it anyway. It's more of an optimization for the platforms that do support it as a fused instruction.
Right, and you'd probably want to, that might be a use case for creating a new thing. Maybe. Anyway, until we see it, we don't have to worry about it.
Yeah, well, and if it's architecture specific or you want those kind of special semantics, it may be a better case to represent it with an intrinsic, because why does everybody who worries about load and store need to worry about that fused thing that's really special?
Yep, you're right.
It might have other side effects as well. Yeah, I think it's just too special scenario for us to leave these opcodes dangling out there. So yeah, I think we're all on the same page.
Oh, okay, so Ben, so for 5149, I guess the answer is no, and we can close it as such with
so I guess the answer 5149, no, we're not going to move them, and we should probably attempt to get rid of them in OpenJ9.
Yeah. Yeah. So I guess once the byteswap, all the family of byteswap opcodes are available in OMR, then we can create an issue in OpenJ9 to deprecate the reverse loads and stores. Okay.
Is this the first time we've managed to try and shrink the set of special opcodes in OpenJ9? I think that's pretty awesome.
Does OpenJ9 have an architecture review board meeting?
I mean, they've got the community call, I think. I think that's about it.
Yeah, I know. So strictly speaking, on this call, we can't make a decision about OpenJ9. Notwithstanding, it would be all the same people. But nonetheless,
No, understandable. Understandable. Yeah, but
we could say we're going to get rid of the J9 project specific code and try to move that down to J9, but that's the most we could really say here.
Right.
Mm-hmm.
Yeah, I certainly though think it's fair to raise the issue against them that we're not going to accept them, and that we don't. And with the enhanced opcodes for swap, we think that they would be well advised to pattern match rather than try to rely on those.
Okay. And then I'll also close 958 as well, which was also a proposal to add the lbyteswap opcode in OMR. So we have that covered. So, okay. Any other discussion you want to have on swapping bytes? No. Okay. Those are the only topics that we had on the agenda for today. So if there's nothing else, I think we can adjourn now. Thanks.
Thanks, sir.
Thanks, everyone.
Thank you. Yep, thank you.